So this will be a series of class actually. So today will be first class, and today's class we will discuss about basics of laser. So we know little bit about laser, right? What is laser? So laser is nothing but a source of light, high intense source of light. It produces high intense light, beam of light. So laser basically stands for light amplification by stimulated emission of radiation. So it is basically a process of emission, but stimulated emission. So how this stimulated emission is important and why it is important, we will discuss about when we will go to the working principle of laser. So these are basic history of laser, which are not important for in the exam point of view, but you can go through it. It was invented in 1958 in Bell Laboratories. Probably you have heard about Bell Laboratories. It's one of the very important chain of laboratories in scientific research. So this is it. Then, if we say that about the types of laser, so it is basically depend on what kind of active material is using for lasing operation, right? So it can be solid laser if we use solid materials, or liquid laser, or gas laser, or free electron laser. So why laser is important? Laser is important due to its some basic properties. So as for example, is monochromicity. It is monochromicity come from the word monochrome. Monochrome. Mono means one. We all know mono means one, and chrome means what? Color. So laser can produce monochromatic light, or light of single color. Okay, single color light, that means light of certain frequency. Laser can produce light of certain frequency. If we need blue light or if we need red light, we can produce separately. So if you see in this figure, so it is so basically this lambda naught depicts the frequency of the light that it produces. Laser, it produces narrow beam in specific direction. So say it is a laser source. From laser source, we will get a beam in specific direction uh, rather than ordinary light of from which we can get light in various direction. And beam divergence is very small in case of laser. This point is very important. Another important point is coherence. So laser is a source of coherent light. What is coherent light? Coherent light means those light which are in phase in space and time. So if you see these two pictures, this is in picture of an incoherent light waves, and this is a picture of a coherent light waves. Obviously, if you see these two picture, then you will easily understand what is coherent light and what is incoherent light. So laser produce coherent light. So this is another important point of properties of laser. So basically, due to these properties, lasers are very important. It is used in various fields. It can be hazardous also because it produces high intense light. How? Because it deposits huge amount of energy within a small area. So if we take a 1 watt laser light, one laser of 1 watt, then the intensity of the light will be equal to the intensity of 100 watt normal bulb. So we can produce high intense light from the laser. These are very important properties of laser. Uh, so if we go through the basic concepts for a laser or how laser works, then we will have of these four phenomena: absorption, spontaneous emission, stimulated emission. This is very important for laser action and population inversion. So what is absorption? Say we have a system of atom and they are in ground state. If we allow a photon to incident on the atom on the ground state, then what will happen? The atom will absorb that light and it will get excited to the higher energy state or excited energy state. This is the procedure of absorption. Say this indicates the incident of a photon. Say it incident on an atom at ground state. This is ground state. Then it will get excited to to the high energy state by absorbing this photon. Now, what will happen to this atom? Will it stay in the high energy state or comes back to the ground state? Depending on this, there can be two types of emission. Say the atoms in the excited state comes back to the ground state at any random time without presence of outer interference, then it will be called as spontaneous emission. So at spontaneous emission, an atom at the high energy state can come back to the ground state at any moment of time, and this process is random process. This is not useful for laser action. So what happens in laser? We said that already. In laser, we get high intense unidirectional or monodirectional light. So this is not important for laser. So for laser, the important phenomenon is the stimulated emission. What happens in stimulated emission? Say we have atoms in the high energy state. They are in high energy state. Now we allow to fall another photon of energy, certain energy, say H2, or which is equal to E2 minus E1, obviously. So we allow certain photon of energy H2 to fall on the atom on the high energy state. What will happen? The atom in the high energy state will jump to the ground state, and it will emit another photon of same wavelength depth of the this incident photon. So from this incident photon, we will get two photons whose direction will be same, whose frequency will be same, or wavelength will be same. Now these two photons will, if we allow them to strike another atom at the energy state, then from that energy state, these two photons will produce another 4 photons. Like that, the numbers of emitted photons will get increases. So in stimulated emission, it is we have to remember these points. The incident photon and the stimulated photon, they are in phase, they have same wavelength and travel in the same direction. So in single picture, if we want to describe the phenomenon, then this is like this. Say these are atoms in the ground state. This is photon, incident photon. They are allowed to incident on this system of atoms. Then say this atom get excited and it goes to the high energy state, so E2 state. Now this atom in the high energy state can come back to the ground state randomly or automatically without interference of the outer interference. Then we will get spontaneous emission. It comes back to it automatically. If it does not come to the ground state automatically, and we have to apply certain photon of certain frequency, then this will be stimulated emission. Say this is in the high energy state. We are again allowing a photon to strike the atom in the high energy state. Then the atom in the high energy state comes back to the ground state, and we get two photons. This photon and another that is emitted from the transition of atom in the high energy state to the lower energy state. So we will get two photons. So this is the basic procedure, or this is the procedure how the absorption and spontaneous emission and stimulated emission process happens. So another important point is population inversion, right? Say we have numbers of atoms. Say here we have huge numbers of atoms in the ground state. We are allowing certain photon to strike the atom in the ground state. Then what happens? The atom get excited in the excited state. If we allow another photon to strike those atoms in the ground state, then what will happen? Say after another strikes of photon, the atom in the ground state get excited into the high energy state. So if we repeat the procedure and make it such that the numbers of atom in the high energy state more than the atom in the ground state. Got it? The numbers of atom in the higher energy state is more than the atom in the ground state. Normally, what happens? Numbers of atoms in the ground state is more than the numbers of atoms in the excited state. If we make the reverse of that, the numbers of atom in the excited state more than the numbers of atom in the ground state, then the phenomenon will be called population inversion. So in population inversion, what happens? Numbers of atom in the excited state is more than the numbers of atom in the ground state. And the process of producing this population inversion is called pumping. The process through which we produce population inversion is called pumping. And it can be obtained optically by allowing high energy light to fall on the atom, or by electrically, that is by applying potential difference across the laser medium, or in case of semiconductor, what we will make the movement of electron in the junctions. So by this way we can produce the population inversion. These are process of pumping. So another important point here is Einstein's coefficient. So Einstein discussed and studied about these two kind of emissions, stimulated emissions and spontaneous emission. So in the process, he used certain parameters to discuss how much emission will take place in a certain time. Here we will use these coefficients. So A21, B1 to B21. So A21 will be related to spontaneous emission. B12 will be related to stimulated absorption, and B21 will be related to the stimulated emission. So A21 from step 2 to 1 move related to the movement of atom from higher energy state to lower energy state, and B21 also related to the movement of atom from high energy state to lower energy state, whereas B12 is related to movement of atom from lower energy state to high energy state. Now the movement of atom from lower energy state to high energy state will depend on obviously how much numbers of atom is there in per unit volume. Say we have these two energy states, E1 and E2. In E1 we have N1 numbers of atom per unit volume, and in energy state E2 we have N2 numbers of atom per unit volume. Now if we want to find out how much this stimulated absorption will happen, then the absorption will obviously depend on two parameters. One, how much atom in the ground state, and another is how much energy, or what is the energy density of the incident photon. So this is absorption probability. So the absorption will be proportional to N1, which is numbers of atom in the ground state, and energy density of the incident photon. So this will, if we use a proportionality constant B12, then absorption probability will be equal to B12 E nu N1. And for spontaneous emission obviously depends only on the numbers of atom in the energy state. It will not depend on the energy density of the incident photon. So it will depend only on the numbers of atom in the high energy state. So spontaneous emission will be proportional to N2, or is equal to A21 N2. Here A21 is the another proportionality constant. Similarly, the stimulated emission will be proportional to E nu N2, or if we use a proportionality constant B21, then stimulated emission will be B21 E nu N2. And in equilibrium condition, what happens? Numbers of absorption will be equal to numbers of emission. So from this equation we can write the energy density E nu will be A21 by B21, 1 by N1 by N2, B12 by B21 minus 1. If you solve this equation, then you will get this equation. Again, from Maxwell's Boltzmann distribution, we know N1 equal to N0 e to the power minus E1 by KT, and N2 equal to N0 e to the power minus E2 by KT. So from here, if we want to find out N1 by N2, Then if we want to find n1 by n2, then what we will get, n1 by n2 equal to e to the power minus e2 minus u1 by kt. So e2 minus u1 will be equal to s nu. So we can write e nu equal to a21 by b21 e to the power s nu by kt 1 by b12 by b21 minus 1. Here this e to the power s nu by kt we have written from this n1 by n2. n1 by n2 equal to e to the power s nu by kt. If you do mathematically and find out n1 by n2, obviously you will get this term e to the power s nu by kt. Actually, you will not get s nu, you will get e2 minus u1. Then e2 minus u1 equal to s nu, so it will be e to the power s nu by kt. But this equation must agree with Planck radiation formula, according to which energy density equal to this 8 pi s nu cube by c cube 1 by e to the power s nu minus s nu by kt minus 1. So if we compare these two equations, then we will find that a21 by b21 equal to this term 8 pi s nu cube by c cube, and this b12 by b21 equal to what? Here it will be equal to 1. So these two equation a21 by b21 equal to 8 pi s nu cube by c cube and b12 by b21 equal to 1. These two are called Einstein's relation.